Hello again. In previous videos we've taken a look at accepting input from the user, dealing with variables and data types, integers and doubles, and in this example we're going to start looking at how we can use instantiable classes. Now it's not the first time we've seen instantiable classes in our Java programming. In previous examples, when we accepted input from the user, we used the scanner class, and the scanner itself is an instantiable class that we made an instance of called keyboard. The only difference here is we're going to start a new problem and we're going to develop an application where we create an instantiable class ourselves. So what we're going to aim to do is we're going to separate all of our input and output, so our input from the user and our output to the user, and we're going to separate that in one class from another class where we do our calculations or our process. Okay? We're going to take a look at this example here, which is to develop an application that accepts a number of meters from the user. The application should then calculate and output the equivalent number of centimeters. And the best place to start when you take a problem like this and you want to write a program, before you even start writing code, is to think, what is your input, process and output for this program? So our input for this program is to accept a number of meters from the user. And that, in this case, I'm going to call m. So I'm going to need a variable to store my meters in, and I'm going to call it m, and I'm going to just deal with whole numbers for this example, so we'll use integers. The next thing to think about is what's my output from the program going to be. My output in this instance is going to be centimeters, and again I'm only going to deal with whole centimeters, so we'll declare it as an int as well. So I have two variables, one to hold the meters and one to hold the centimeters. I've called them m and cm because sometimes meters and centimeters are words we tend to spell incorrectly, and if you're unsure that you're going to be consistent throughout the program, save yourself the debugging later on and call them m and cm, and it'll make just as much sense to you. The next thing to do then, once we've got our input and our output, is to think what's our process going to be. So how do I get my output using my input? And the process in this instance to get the centimeters is to multiply the number of meters by 100, because there's 100 centimeters in a meter. So that's my input, process and output. And using that then, I can construct an object diagram. Now we haven't really looked in too much detail at object diagrams in the past, but we'll take a look at an object diagram for this program. The first thing we have is we have a box representing our class, our app class, measure app. So I'm going to call this one measure. Okay, measure app is my app class, and that's the class that has my main method. So much like the classes that we would have been developing in previous examples. This class is going to use two variables, int m and int cm for centimeters. We're also going to make use of another class, and that particular class is measure. Okay, so measure is where we're going to do our calculations. So we're going to have a method in this class called compute, and in that method we'll do our calculations to calculate how many centimeters in that number of meters. But in order to get the number of centimeters, we need the number of meters, and that's being entered into measure app, because measure app is where the input and output is handled. So we have to take that value of meters from measure app and we have to put it into measure. And the only way to do that is by using a set m method or set meters method. So our set methods correspond with our input. We should have one set method for every value that is input by the user, and that helps us get the value of m from measure app into measure. Once we've done that, we can run our compute method and calculate how many centimeters we have, but then we have the same problem. We need to get the value of centimeters back to measure app, and then it can be output from measure app. So the way that we do that is using the getCM method. Okay, so again, your get method corresponds with your output. You have one get method for every output variable that you're going to print to the user. And finally, when we used scanner, we had to make an instance of the scanner class called keyboard. So in this case, we're going to use measure, and we're going to make an instance of measure called myMeasure. The best way really to see all this coming together now is for us to switch to TextPad and to do an example using TextPad and to write the code for both classes, measure and measure app. So let's take a look at that now. Okay, so here we are in TextPad, and I've opened two new files, one called measure.java and one called measureapp.java. Again, just be careful to save both of these files in the same folder on your machine somewhere. I'm going to start with the measure.java file because that is the instantiable class, and we should always start by developing our instantiable class first. We start our instantiable class, as with all other classes, with a comment. Your comment should include the name of the file, measure.java. It should contain the name of the author, F. Sheridan, and it should contain the date, the 11th of October 2013. And you close it with a */. We start this class with, like any other public class, measure, making sure that measure matches exactly to what we saved the class as. Our first step in an instantiable class then is to declare your data members, which is pretty much just your variables. The only real difference is that all of our data members should be declared as private, and that simply means that they can't be accessed by any other class outside of this one. So it just means that they're protected a little, they're private to this class. The two variables I wanted were int m and int cm for centimeters, meters and centimeters. The other new part that we have here is a constructor, and the constructor is a very important part of an instantiable class. It's a method which, when we create an instance of the measure class, it's responsible for making that instance. It's part of that process. So it's important that we have it in here. Public measure. The constructor is always public and it gets the same name as the class. So measure here must be spelled exactly the same as measure in the class name. We open a curly bracket, and because it's a method we need to make sure we close that curly bracket also. And then inside this, all that we're going to do, constructors have a lot of functions, but all that we're going to do for now is we're going to take each of our variables and we're going to initialize them to 0 to give them default values. So because they're integers, we're going to give them default values by initializing them to 0. And that's our constructor. The next part is to write our set methods. So we saw the set methods in the object diagram. We have just one set method in this instance, but typically we should have one for every input. So because we have one input value in this application, we have one set method. If we had two input values, we would have two set methods. Public void set m for set meters. In the brackets then of this method, we have to say int m. And this represents the meters value that's coming from the app class from when the user typed it in. That value then needs to get copied into the m from this class. So we've declared a variable m at the top of this class, and we want the value that we've just got here in the brackets that's just been received from the other class to be copied in. So the code is this.m equals m, and that simply means copy m that just came into this method into the m variable for this class. And all of our set methods are going to follow that structure. The next thing we have to have is our compute method. And your compute method is simply your process. So we already decided earlier on in our IPO what our process was going to be. And our process is just that simple line of code, centimeters equals meters times 100. So now let's write our compute method. Public void compute. I'll explain the void part now in just a second when we get to our get methods. So you'll see here there's nothing in the brackets of the compute method, and that's because the compute method isn't responsible for accepting any values from the app class. The compute method is simply going to carry out your instructions for your calculations, which is cm is equal to m times 100. And then we close our compute method. So we have to remember the whole way down to be closing the curly brackets for our methods, okay? It's important that we don't leave those out. Now we're going to do our get method. Again, it's public, so you'll see our data members were private and our methods are all public. And that's because that is what allows us to gain access to the data members with our set method and our get method. And we need to access those from the other class, and you'll see that in a moment. Now your get method, I'll just put a comment in here. Get method, again, we should have one for every output. Okay, in this instance we have only one output, so we'll have only one get method. And the get methods aren't void. The void in these other methods represents the return type. So any value that we're sending back to the app class. And in this instance, we're not sending any value back. The set method is responsible for bringing a value in. The compute method doesn't bring anything in, doesn't send anything out, but the get method is where we're going to send a value out to the app class. And in this instance, the value that we're sending out is centimeters, or cm. And the data type for that is int. So our void in this instance becomes int. Public int get cm. Again, we've nothing in the round brackets here, and that's because this method isn't responsible for accepting any values from the app class, it's just outputting them. Inside then, we return cm, so that's where we're actually sending the value back out to the app class. We close our curly bracket for this method, and then finally we close our curly bracket for the whole class. So we opened a curly bracket at the start, we have to make sure to close it at the end. And that's our instantiable class. So Control on the and 1 on the keyboard will compile, and we'll see if we have any errors. No, we've had tool completed successfully, and once that's compiled, we're ready to go on the next class. If we try to run this, we're going to get the error, main method not found in class measure. And that's because instantiable classes don't have a main method. They're not designed to run by themselves. Their purpose is to be instantiated by other classes and to be used by other classes, but not to stand alone by themselves. So this one's not supposed to run. So long as you get it compiling, you're ready to move on then to your measure app. So let's do that. Let's take a look at measure app. Again, we're going to start with a comment at the top, very similar to what we had in our instantiable class. So I'll copy that one in. And in this instance, instead of just being measure, it's measure app. We start our class, public class, measure app. And inside here then we have our main method. Public static void main string args. Okay, obviously these both need to be closed. If you're inclined to forget, close them now so that you don't forget them later. In here then, the first thing we do is we declare our variables. Our variables in this instance are int meters and centimeters, so m and cm. I can declare them both on the same line because they're both int, and I just separate them with a comma. Then we're going to declare objects. And the objects are anything that we're going to use outside of this class, so any other classes that we want to access. The first, which you'll be familiar with from the last example we did, is scanner. And we're going to call scanner keyboard. But we're also now going to use the instantiable class we just wrote, measure, and we said in our object diagram we were going to call it my measure. Okay? Now remember, when we're using the scanner class is not one of our own, it's part of the util package. So we have to pop back up here outside of our class and import java.util.scanner. And that allows us to use the scanner class. When we've declared our objects, the next step is in creating the objects. So keyboard is a new instance of scanner, and you'll have seen that before. This one is used for system input, so the brackets have to have system.in. And then measure follows the very same format. So my measure equals new measure. In this instance, it's not going to be used for system input or anything like it, so we don't need anything in the round brackets. We just need to make a new instance of measure. Okay, and that instance is called my measure. Then we're going to do our input. We'll have our output. And then we'll have our input, our process, and then we'll have our output. So for the input, we first give the user an instruction, system.out.println please enter a number of meters. So we issue an instruction to the user, and then we tell Scanner to grab the value that they entered and store it in centimeters or in meters. So m equals keyboard.next int, because meters is an int. That's going to grab the next value that the user enters into the keyboard, and it's going to store it in m. The next step, and this is the important bit when we're using instantiable classes, we need to send this value m to the instantiable class. So we say go to the myMeasure class and go to the setM method, and into the brackets give it m. And at this point, that value m in the brackets here arrives in the measure class here. And then it's copied in here to run the process with. So we'll pop back to our app class now, and let's tell it to run the process. So go to the myMeasure class and do the compute method. Now again, the compute method is not expecting anything in the brackets, so we're just telling it find the compute method in the myMeasure class and execute whatever code is in there. So in the measure class, that's going to run our formula to calculate our centimeters. Now our value for centimeters is stored in here, and we want to use our getCM method to return it to the app class. So my output has to begin with cm equals go to the myMeasure class and get the centimeters. So that's going to get the centimeters from the myMeasure class and store the value in cm. And once we've done that, then it's simply another print statement, system.out.println the total number of centimeters is plus cm. I've already closed my two curly brackets, so I'm ready to compile. And now I'm getting a couple of errors, so let's take a look. They may be typos. Error, cannot find symbol measure. So it's having difficulty. Oh, it's having difficulty with this line of code here. Alright. Now, the best way, there's a couple of ways for me to find this. It tells me in the error, Java line 14, so I can turn on my line numbers and have a look. And to do that, I go to View, Line Numbers, and that gives me my line numbers along the side of my code. Or alternatively, I can double click the error in TextPad and it brings my mouse cursor to the line of code where the problem is. And if you take a look here, then MEASURE, my MEASURE, and let's just see, have I saved them in the same place? So if it's having difficulty from the app class seeing the instantiable class, it's a possibility that you haven't stored them both in the same folder. My measure class is stored in programming videos, examples, and measure app is stored in documents. So I haven't got them in the same place. So I'm going to just resave this now, and I'm going to pop it into the same folder as the instantiable class. So that's an important one to watch out for. Programming videos and examples, and save. And now if I compile it again, actually it's gotten rid of that error altogether. So it's important to make sure you've saved both files in the same folder so that they can see each other and they can interact with each other. So we run the program with Control and 2 on the keyboard. Please enter a number of meters. If we enter 4, the total number of centimeters is 400. So there you have it. A very simple example, accepting a value from the user, processing it using an instantiable class, and giving output again using the app class. Things to remember are to make sure to save both of your files in the same folder. Your instantiable class is just simply the name of your instantiable class, so measure. Your constructor should get that same name. You need to save it exactly the same way again. And then your app class is measure app, and this is the one with the public static void main string arg. So this is the one with the main method. It's the one that runs. The instantiable class doesn't. And once you've got all those building blocks put together, you can create an instantiable class and app class for any application with any number of inputs and any number of outputs. It's just a case of following the example that's here and following the same structure. So off you go now and give it a try for yourself.